Okay, we're going to use integration by parts to integrate theta times the cosine of pi theta d theta. So just a reminder that our integration by parts formula is the integral of u times dv equals u times v minus the integral of v times du. So in that case, we need to identify two parts. So as I mentioned in explaining things, you could try a u substitution with this guy and let u be the pi theta, but then the du is just pi. So there's no way to get rid of this theta on the outside. So it's not really helpful. So what we're going to do is we're going to let u be the theta, and we're going to let cosine pi theta be and d theta be dv. So what does that mean? It means that if u is theta, then du equals d theta. Okay. Well, we could just call that 1. So let's do that. It might be a little bit easier, depending on what's going to happen in this problem. But we'll call it 1 d theta in this case. And dv we want to integrate, so v would be the integral of cosine would be sine, but this is a u substitution, so sine pi theta, but it will be divided by the derivative of that pi theta, which will be 1 over pi. So in this case we did derivative on the u and we did an integration on the dv. So one part we're going to take the derivative of, and the other part we're going to integrate. So once we have that, we're going to come back and we're going to plug in the parts and see what happens. So the integral of theta times cosine of pi theta d theta equals u times v. Well, that's theta times 1 over pi sine of pi theta. So let's make sure we understand where everything came from here. Here is u and here is v. So it's going to be minus, continue on the formula, the integral of v, which is 1 over pi sine of pi theta, times du, which was just 1 d theta, so d theta. So in this case we got minus the integral of v du. Now maybe it looks better, maybe it doesn't, but the thing to keep in mind is this part out front, the u times v, is already integrated, so that's just going to stay the way it is. Okay. Now the other part we have not integrated, so we've integrated part, we still have part left to integrate. Integration by parts. Okay, so then if we take a look at the second part, we can bring all this down. We'll clean it up a little bit. It'll be theta over pi sine of pi theta, and then out here we'll have minus. So we're going to integrate this thing over here, 1 over pi sine pi theta. The main thing here is the 1 over pi stays because it's a coefficient. The integral of sine is negative cosine. Negative cosine of pi theta. And then from the u substitution you'll get 1 over pi again. So in that case, what we get in here is the coefficient kind of stays there, and then the u part is kind of hanging out. Okay, so if you need to see that, you could have a u being pi theta, and then du equals pi d theta. So that's where the integration comes from, with the theta out front. So let me slide this up just a little bit because I'm going to clean it up, because we are done. We do need to do one more thing technically. Go back to black. So this will be theta over pi sine of pi theta, and I've got two minuses here, so we'll change that to plus, and I've got 2 pi's on the bottom, so 1 over pi squared cosine of pi theta, and then we really need a plus c out at the end of it to show us that it's an indefinite integral. So the thing that we started with was a product of two things where U substitution wouldn't work. So we kind of backtracked using this integration by parts, and we got part of the integral, and then we still had part left to work with. In this case, that second part worked out very nice because we knew the integral of that VDU combination. Sometimes we don't know that right off the bat. Thank you.